Hi, Pre-Cal. We are going to keep working on arithmetic sequences and series, and today we are actually going to do the series part of that lesson. And if you remember from before, we talked about series, and what you are doing with a series is you're adding things, you're adding up those terms, and that's why we saw the sigma, which meant that we were adding. So we're going to start these and work on lots of examples. But before we get to an actual formula, let's read this and deconstruct like what it's asking us to do and what that means we have to do to solve it. This says, find the fifth partial sum of the following arithmetic sequence. So fifth partial sum means we're finding a partial sum for the sequence, which is saying that, see how the sequence continues on, it has the ... They didn't give us all of the numbers. If they had given us all the numbers and we were going to add them all up, add up all the numbers that they gave us, then that'd be a finite sum. But if we are asked to add up like a certain number of them, that's a partial sum because it's part of all of the numbers, part of the sequence. So when we're just adding up parts of it instead of the whole sequence, it's a partial. Remember, arithmetic means that the difference between them is all the same. So fifth means we're just going to add the first five. So 1, 2, 3, 4, 5. So 3 plus 5 is 8, plus 7 is 15. Plus 9 plus 11 is 35. So the answer is 35. And we got that by adding 3 plus 5 plus 7 plus 9 plus 11. Okay, that's not so bad. Then it says find the seventh partial sum of the following sequence. So how many are we adding? We're adding 7 of them. So 1, 2, 3, 4, 5. There's only 5 of them, but I gotta add 7. Okay, well, I can find them. What is the difference? I got to find D, the difference. So that's where you do 9 minus 13, and that is negative 4. So the difference is negative 4. So if that's negative 3, then you get negative 7, and then you get negative 11. All right, so to add those up, 13 plus 9 plus 5 plus 1 plus negative 3 plus negative 7 plus, oops, I keep doing commas, negative 11. 13 plus 9 plus 5 plus 1 plus negative 3 plus negative 7 plus negative 11 gives us 7. Okay, so that is how you add them. Now, imagine being asked to add the 100th partial sum. That sounds ridiculous, and I would not want to have to do that. So guess what? There is a formula that you can come up with that will help you do that more efficiently, so you don't have to individually add all of them up. So to find the sum of a finite arithmetic sequence, and that just means if you have all the numbers that you're going to add up from the first to the last, to find the sum of your sequence. And so we're going to do S sub n, which is standing for the sum of your sequence with n terms. So where n is the last term that you're adding, it is equal to n over 2, and n is the number of terms. So n divided by 2 times a sub 1. So remember, what's a sub 1 mean? That's your first term, right? Plus a sub n, the last term, where a sub n is the last term of the sequence, or the last term that you're just adding. So this one says find the 100th partial sum of the following arithmetic sequence. Okay, so So, I need to know the 100th number. Because I am not going to go through and calculate all 100 numbers and then add them together. So what I'm going to do is find the 100th number. So first, we're going to find the 100th number. So how do I do that? We have to use the formula that we used in our last lesson on this. And so what you do is you have your common difference. So what's our common difference here? Oh, 1. We're just adding 1. So the common difference is 1. And so you do a sub, I'll write it up here. A sub n equals a sub 1 plus n minus 1 times your difference, or you can have your difference in front. That's how I was writing it. So a sub 100 equals a sub 1, which is 1, plus the difference is 1 times 100 minus 1, so 99. So it is going to equal 1 plus 99, so it equals 100. Oh my gosh, does that make sense? Yes, that makes sense that the 100th number is 100 because it's just going up to 1, right? Now, so did I really have to do that? No, but in the future, I will have to do that. Like the next one where it's not as obvious. Wasn't even paying attention. So step 2, once I found it, now I'm going to use this formula. The sum of the first 100 terms is 100 over 2. So the only things that change here are your n and then these two numbers. Okay, so 100 over 2 times a sub 1, our first number, 1, plus a sub n, 100. So this is a fast way if you want to like win something or like challenge someone. You're like, okay, first person to add the first 100 digits wins. And so if they're sitting there and they're going, okay, 1 plus 2 plus 3 plus 4, you can beat them by using this formula. So 100 divided by 2 is 50. So 50 times 101, 50 times 101, or now that you know this, you can just give the answer, is 50-50. Wow, that is so cool. 50-50. If you add up the terms 1 through 100, that's what you get. All right, so now it says find the 149th partial sum of the following arithmetic sequence. So let's see. I am not counting to 149. What's our difference? 2 minus a negative 1 becomes 2 plus 1, so it's 3. So each time we're adding 3. So I need to find the 149th term. So to do that, I will do a sub 149 equals my first term, negative 1, plus the distance between them, 3, times n minus 1, so 149 minus 1. So this will be 148, right? So negative 1 plus 3 times 148 is 444. So it is 443 is our 149th term. So that means then the sum of the first 149 terms of this sequence is 149 divided by 2 times negative 1 plus this number, 443, the 149th number. All right, so now we've got 149 over 2 times 442. So let's do this. 442 divided by 2 is 221. I'm just dividing 2 into this because it's easier, because it's even. So 221 times 149, and I get 370. Wow, that is the sum. I'm glad I didn't have to do that by hand. Now this next one is giving us a sum, but it's giving it to us in sigma. So it's saying the same thing just in a different way, and so we're going to decipher this. It says find the sum of the first 100. So we're starting at the first term and we're going through to the 100th term. So what's a sub 1 going to be? 2 plus 3 times 1. So that will be 2 plus 3, so 5. And then what is the 100th term going to be? 2 plus 3 times 100 is 302. So now I can find the sum of these numbers by doing sum of 100 equals, how many numbers do we have? We have 100 numbers divided by 2 times the first number plus the second number. So we've got, that's 50 times 305. So we've got 50 times 305, and that gives us 15280. That is the sum of the first 100 digits in this sequence. All right, next one. It says the third term of an arithmetic sequence is 8, and the 16th term is 47. Find A1 and D and construct the sequence. Oh my, cool. Okay, so we know A sub 3 is 8. And we know A sub 16 is 47. All right, so find A sub 1, the distance. Okay, so first we can find the distance. So if we do A sub 16 equals A sub 3 plus the distance, which we don't know, times how many differences are we adding to get from the third term to the 16th term? And that's what we did earlier. We did 16 minus 3 gives us 13. We did that in our last lesson, so 13. So I should be doing this, and 16th term is 47 equals 8 plus 13 times the distance. Okay, so now I will subtract 8. So 47 minus 8 gives us 39 equals 13D divided by 13. And that's 3. So the D is 3. Okay, so then I can find A sub 1, or I could just subtract 3 from 8 twice. Yeah, so let's see. So we know A sub 1, A sub 2, A sub 3. We could just work backwards. So if I subtract 3, then I get 5, and if I subtract 3, then I get 2. So my first number is 2. So I found A sub 1. I found my distance, and now I'm going to construct this sequence. I think what they mean is write the formula. So it will be Oh, like this is what we did last time. Okay, so how do we find something? A sub n equals a sub 1 plus 3 times n minus 1. Right? So a sub 1 is 2, so this will be 2 plus 3 times n minus 1. And then we're going to simplify it. So when we simplify, we get 2 plus 3n minus 3. So a sub n equals 3n minus 1. I get that by combining these two. All right, so there's your formula. More examples and probably really popular problems that they ask you to do on like an SAT or like trivia or I don't know, something like that. Find the sum of the first 200 natural numbers. Well, this is like just like the one we did earlier. Natural numbers are where how you naturally are counting 1, 2, 3, 4. So if I start at 1, 2, 3, and I go all the way to 200, those are my first 200 natural numbers. I want to find the sum. So the sum of 200 numbers is 200 divided by 2 times the first number plus the last number. So that is, in my head, that's 100 times 201. So the sum is 20100. So 20,100. Wow, that's so crazy. If you added 1 plus 2 plus 3 plus 4 plus 5 all the way to 200, you would get 20,000. That's crazy. You could do that with money. You could, every day you're going to put in an additional $1 into a jar. You do it for 200 days, less than a year, you're going to have a lot of money. That's pretty cool. Okay. Find the sum of the first 100 even numbers. So, do we start with 0? Or do we start with 2? 2, 4, 6, 8, blah, blah, blah. It'll be 102. Would be the 100. That would be the 100th even number. First, second, third, fourth. Yeah. Okay. So find the sum. So we'll have the sum of how many numbers are we adding? 100 numbers equals 100 numbers divided by 2 times the first number plus the last number. So that's 50 times 104. So 104 times, 5,200. So much small. Oh, wait. That's not right. This isn't the right number. I'm sorry. Wait, is it? Wait, what am I thinking now? Wait. No, that wouldn't be one. Would that be 100? No, that's not going to be 100 numbers. Man, I wonder if you guys caught me. Let's try this again. So let's erase this. How am I going to, let's just find it. Let's do it with the formula. And then we'll erase this also. And we'll change this. And we'll obviously change our answer. So let's see. To find a sub 100, we would do the first number plus the distance between them is 2 times 99. Silly me. 99 times 2 is 198 plus 2 is 200. So the 100th number is 200. Wow, I was way off. 200. So 202. So 202 times 50 is 10,100. There we go. That's more like it. All right. Find the sum of the first odd numbers, 1, 2. Find the sum of the first odd numbers. What first odd numbers? How many? All of them? Oh, let's just do this. Find the sum of the odd numbers, 1 through 100. So 1, 3, 5, 7, blah, 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 all the way to 100 is not odd, so 99. How many numbers is that? 50? 50 numbers. So n equals 50. So the sum of the first 50 numbers that are odd is 50 divided by 2 times 1 plus 99. So this is 25 times 100. So that is 2500. 2,500. You add the odd numbers 0 to 100. So, oh yeah, so that's like different than that question. Okay, more examples. Find the sum of the first 15 terms, okay, of the arithmetic sequence. So, here, I know I start with 4, and I need to find the 15th term. So a sub 15 is a sub 1 plus the distance between them. 7 minus 4 is 3. So 3 times 15 minus 1. So this will be 4 plus 3 times 14. So 14 times 3 is 42. So 46 is the 15th term. So the sum of the first 15 terms is how many numbers? 15 divided by 2 times 4 plus 46. So let's see. 15 over 2 times 50. So you can also do that in your calculator. 15 divided by 2, enter, times 50, enter 375. Or you can do 15 times 50 and then divide that by 2 and you get 375. Or you can do 15 times 25 because 50 divided by 2 is 25. And 15 times 25 is, would you guess that? 375. All of those ways work. So 375. And I believe that is it. Good job, guys.